right, we're going to start with lesson today, and then we'll go from that into taking a look at some problems from yesterday's homework to make sure you have this whole derivative thing under control, because today we're going backwards. So there's a couple different components to the lesson today. If you are doing okay with integrals, the lesson shouldn't be a big deal. So for instance, if you have the UDU system under control, you should be okay. We're not really doing anything new except just taking the lesson from yesterday and putting it in reverse. However, if you're still struggling with antiderivatives and integrals, this could be a little tricky, especially the UDU process. So we'll go slow, we'll take some time, we'll learn all about how to integrate natural language. Okay. So, we're going to talk about the log rule for integration. It's in capitals there, so it's kind of important. We're going to finish up with the trig function. So you'll recall we've only talked about the antiderivative or the integral of two trig functions, sine and cosine. We haven't done the other four. We got some weird ones like secant squared, tangent squared, whatever that weird one, some of those, you're like, when does this ever apply? But the 6 basic trig functions we'll be able to finish up today. And you should be able to balance a checkbook. Does anybody here have a checkbook?
I do, but
Do you know what do the rest of you know what a checkbook is?
yes.
Okay, just checking. What?
What's like the title of this lesson?
How to succeed in life?
Oh, like what was it? You skipped it. Okay. The natural. Thank you.
You're welcome. Okay, so we know this already. We did it yesterday. Just to keep things proper, in case some calculus master comes in here, I put absolute value bars back in there. So it takes into account all the good stuff. Because we want, remember, you can't take the natural log of a negative number, so that guarantees that we're always going to have a positive number there. No problem. But we knew that already. The derivative of the natural log is u prime over u. I put the left side on there. Really all we've been doing is the right-hand side. Any problems so far? I hope not. So, put it in reverse. Now, before we put it in reverse, let's talk about one thing that may or may not have been a concern. So we had this. F of t dt. Okay, so you'll recall this. Second fundamental theorem of calculus. We take the integral first and you get a plus c. Well, actually, you wouldn't get a plus c because we're plugging in values there. Then you take the derivative and the constant disappears. That versus this. And my notation's a little bit sloppy, but you get the idea here. Here we're taking the integral second, so that you will, if we don't have limits of integration on here, you're going to end up with a plus c. Okay. We didn't do a lot of this on the right-hand side. We did do a lot on the left-hand side, because again, it's the second fundamental theorem of calculus. And the reason I went over this is because it becomes relevant to what we're going to do today, and that is taking the antiderivative of some of these things. In other words, putting this thing in reverse, we end up with that. The integral of 1 over x is the natural log of x plus c. So yeah, one thing you could say is, well, it's just an antiderivative with no limits of integration, so of course there's going to be a plus c. But going from the top to the bottom, you understand now why there is a plus c, because we're doing the derivative first, then the. Why did it bell ring twice when you walked in the room? Are you special or something? Does that happen when you walk into every classroom? Oh. Bridget's here. Ding, ding.
Hi, Bridget.
Whose signature is this?
Sizen, sir?
And she gave it to me on the flap of a Christmas envelope.
She said you can keep the sticker.
Oh, it's like a Hallmark moment. Thank you. That's wonderful. I'll put it on the board later. Any problems? Good. Okay, now notice, we haven't done the antiderivative of natural logs. We don't know how to do that yet. This is the antiderivative of 1 over x. or the derivative of natural log. Are we good? That's pretty much the lesson. Now we've got some examples. So do that, please. We'll start simple and ramp it up pretty quickly. Any problems? What'd you do first? Okay. I would have done the same thing. Put the constant out in front so we don't have to worry about it. What's the antiderivative of 1 over x? Natural log of the absolute value of x. Plus c. Indefinite integral has to have a plus c on there. Done. Why do you two have the same shirt on?
Show choir.
Thank you for that clarification. Drew?
Maybe you went over this yesterday, but why are there absolute values over the x?
Other than the fact that that's what the theorem says, it's a common practice because if you'll remember yesterday or the day before, we tried taking the natural log of a negative number, and it doesn't work.
Yeah.
So you slap the natural log or the
Just because
absolute value bars in there so that we don't accidentally put in a negative number and cause all kinds of problems. Okay. Any issues there? Okay. Let's ramp it up a little bit. Oh, I forgot this. I could, if I was feeling all fancies in my pantsies, I could do that. That's why I include the paragraph, because I forgot that. So I did two things there. I used a log property and brought the 2 up in front to a power, and then I made the absolute value bars go away, and as that explains, that's what allowed me to get rid of the absolute value bars, because that number would always be guaranteed to be positive, addressing the question you just asked there. Now that it's positive, you can get rid of it. So moving forward, I would recommend. Yes.
So if it was like a 3 instead of a 2, you
Stays there. You leave the absolute value bar. Okay. Moving forward, I would suggest the following. I would leave them there. This is not wrong. Okay? This is just showing off. However, if they're supposed to be there and you just decide to get rid of them, that would be wrong. So it's better to put them there and not need them than to need them and not have them there. Did I say that right?
Yeah.
Okay, good. Comprende? Sí, bien. Okay, here we go. Come on. Time to run with the big dogs. Remember, no quotient rule in integrals. Which means you have to do what? I don't know. Anybody? Bueller? How about a U to U problem? It's not cool.
I think it's cruel.
Okay. It hasn't been that long. Oh, please. Are you kidding me? What's U? Let's even back up. What are your choices for U? X. That would be really dumb, but yes, that is a choice. Correct. Dx would be a choice also. Also very dumb and wrong. Okay, what are my other choices? X to the fourth plus 3x. Or 4x cubed plus 3. The numerator, the denominator, or you could do the whole shooting match. That would be really bad. What was the rule we talked about with u? What do I want u to be here?
Biggest power.
The higher power. So I'm going to do x to the 4th plus 3x. Now what?
Find the derivative.
Derivative. Did we choose wisely? You bet we did, because that cancels with that, and this puppy becomes 1 over u du. Easy peasy lemon squeezy. What's the antiderivative of 1 over u? Natural log of? No. Absolute value of u plus c, which means we get the natural log of x to the 4th plus 3x plus c. Do we know that x to the 4th plus 3x is always going to be positive? No. So therefore, we're just going to leave the absolute value bars there. And in fact, I'm probably going to get in the habit of not even asking that question anymore. Just leave them in there. Because they're not wrong if they're there. Okay. Little refresher on UDUs. Getting the brain juices flowing again. Let's try something completely new.
Oh no.
Yeah, you're not going to like this one. Question here in the back.
So can you not just like look at that one and know that the top one is the derivative of the, or that the numerator is the derivative of the denominator and just put the denominator?
Oh, you can. That's how I do it.
Okay. So I can do, like if I do that on a test?
Oh no. You have to show the UDU process, because you're getting the answer and showing how you got to that answer are two different things. So the AP test and your AP teacher are testing not only can you get the answer, but also what process you go through to get there. So yeah, you still need to establish the U and how you went from the x integral to the u integral, and then take the antiderivative. I know. You do it enough that you just see it and it, bingo.
But even on the AP test, you need to show maximum work all the time.
On the free response, yes. On the multiple choice, you can, like on multiple choice problem,
Yeah.
just pick the right answer. Okay. Okay, so yeah, this comes up. Again, you're not going to like it, but I'm going to show you anyways because it is common. Okay. Now, unlike the previous problem we just did, the numerator is not the derivative of the denominator, nor is the denominator the derivative of the numerator. We've got two things that are equal. So we have to come up with a sneaky technique, and this one is pretty sneaky, and you probably wouldn't have gotten it on your own. But I'm going to split the fraction. You know how to split the fraction. This is a weird one because you have to split the fraction in a very strange way. So, for instance, I could split the fraction as doing x squared over x squared plus 1, plus x over x squared plus 1, plus 1 over x squared plus 1. Which seems on the surface like that would be fine, but it's actually a train. So, any ideas?
Maybe you can say.
Ashton?
X squared plus 1 over x squared plus 1 plus x over x squared plus 1.
Well done. That's a plus sign, not a 4, by the way. There we go.
I have a question.
Certainly.
So how would you know to do that? Me too. How would I know that the other side doesn't have? Yeah, like how do you? Is it just with practice?
Because nothing else would work. Yeah. All the other techniques we've discussed, which is UDU problems, choosing a variety of UDU problems wouldn't work, and so therefore you've got to look at a different technique, and in this case you try splitting the fraction. And then when you realize it's a splitting the fraction problem, you also have to realize how you're going to split the fraction. It's fun, right? What's the left-hand side? What's x squared plus 1 over x squared plus 1? 1. Antiderivative of 1 is? Whoa. I'm sorry. What's the antiderivative of 1? X. Plus c, but I'll wait on the plus c because I only need 1 plus c. Plus this guy. How do I do that guy? U du. What's u? X squared plus 1. Now we're getting there. du is equal to 2x dx is equal to 1 over 2x du. Ooh, I'm happy. Whoopsh, whoopsh. Plus 1/2 times the integral of 1 over u du. And you start to see a pattern here that the integral I'm left with is that natural log integral we've talked about since the beginning. Okay. This is just going to stay x. I'm not changing that at all. Plus 1/2 times the natural log of the absolute value of u, and don't forget the plus c. Now, we do get a plus c from here. We do get a plus c from here, but what's c plus c? C, not 2c. Just c. You only need one c. Question?
Wait, so how did you put the dx equals du whatever that is? Where did that go?
This?
Yeah.
The x, I didn't do the extra step. I thought we might be past that, but I can go over it again. I would have done a full substitution and turned that dx into that mess, but the x's would have canceled, so I canceled my x's there and then slapped that 1/2 off. Yeah, here. Sorry, I blame myself. There we go. Okay. Make sense? Now notice the only new thing up there is, well, there's two things. Number one is this antiderivative of 1 over u, and then this weird way of splitting the fraction, even though we've done fraction splitting problems before. Okay? That having been said, how would we do this? Have we talked about a differential equation? Okay. We'll spend a lot of time on differential equations. Differential equations are basically, here's a derivative, what's the function? Okay. Which is the basis of an integral, but usually a differential equation also involves finding that one particular solution, not a variety of solutions. And the only reason I'm doing this particular example is because it seems to be fairly common. And so I'm going to show you how to do this, but then at the end I'm going to give you a theorem. So now you need to make a decision. Are you a memorizer where you just write that down on a flashcard and you remember this particular theorem? Or are you going to want to solve this when it pops up? I think it's important that you see how to solve it in case you forget the theorem. But again, some of you are memorizers and you're just going to want to memorize it, whatever works for you. Okay, so I'm going to take an antiderivative of both sides, because if I have a derivative and I want to get rid of it to go back to the original function, I have to take an antiderivative. So I got that mess. What are my choices for u? Well, first of all, I'm making a big jump there. Do you see that that's a u du problem, other than the fact that I just told you? Yeah. Because we've got a product rule wrapped inside a quotient rule, so we probably have to do something different. What are my choices for u? Ashton?
X, L, and X.
I can do the whole thing, good, or just x, or natural log of x. Which one do you want to try? Natural log of x? Okay. And again, the worst thing that could happen is it doesn't work. What's the derivative of the natural log of x? 1 over x. Did we choose wisely? No. Because this, which is now in the numerator, is going to cancel with that down in the denominator. Go back to blue. This becomes y is equal to the antiderivative of 1 over u du. Let me stop there for a second, make sure everybody's with me. We're good?
How did you know that was in the numerator? Because we would put that over 1.
Yeah, because I solved for dx here
Okay.
by multiplying both sides by x. Okay. Which makes y equal to antiderivative of 1 over u. Natural log of the absolute value of u, which we know is, ooh, that's weird. The natural log of the the natural log of the absolute value of the natural log of x. We'll see. And I think on the derivative stuff, you were doing the derivatives of functions like this, right?
Yes.
Okay. So this, let me skip all that, blah, 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 that's all right. Oh, look, I did the work already. Okay, great. There's the theorem. So again, two choices. Pick one or choose both, whatever. But again, this seems to pop up frequently, so you should understand how to find it. Okay, almost done. You got to finish those other 4 trig functions. So we need to figure out how to take the antiderivative of tangent, secant, cosecant, and cotangent. How would I find the knowing what I now know, knowing what we all know, how would I go about finding the antiderivative of tangent?
Previous slide.
In the pile. So, I don't understand how that equals that.
Well, the antiderivative of 1 over u is the natural log of u. And u we chose over here to be the natural log of x.
Oh,
So I did a u, I put the u back in there.
Okay. Oh, okay. Yeah, I see.
Good. Okay, so again, how would I take the antiderivative of tangent?
Do you do sine over cosine?
Well, we can try it. What's worse that could happen? That's the same thing as the integral of sine of x. Whoops. What am I doing? Cosine of x.
And then you do like a u problems? Or no?
What's u?
Cosine of x?
Cosine? Okay.
Maybe?
What's the derivative of cosine? Negative sine.
Wow.
Which means that dx is equal to 1 over the opposite of the sine of x du. Canceling. Ooh. Lovely. This becomes negative absolute or integral of 1 over u du. Which is the opposite of the natural log of the absolute value of the cosine of x plus c. Well done. Pregunta.
How do I know to use cosine in that sign?
Shall we do it with sine and see what happens?
But I just know that it wouldn't be negative.
What happens if you choose sine is that when you take the derivative, you get cosine. You divide it to the other side, so you have 1 over cosine. And instead of canceling, it squares this. So now all of a sudden you're taking the antiderivative of 1 over u squared. Which I don't... might work.
Let's try it.
No, let's not. No, let's not. That's
What are your chances of it working though? You're like, it might.
probably pretty good. I mean, you know.
Like 75-25.
Oh, I'm not a math guy.
Yeah. Me neither.
Okay, so just for giggles, so that's sine, cosine, tangent. How would we do secant? Yeah. And then cosecant and cotangent, same thing, just flip it over. And so that gets us to the clicker. Yeah, oh look, we did it. Okay. Okay, so there's all the other ones. I'll save you the hassles of going through each one. So you'll notice that the bottom 4 all start to incorporate the natural log stuff, which is why we didn't do them until now. Because it gets ugly.
How come that first one?
How come the first one doesn't have the what? Because there's no natural log. Yeah. It's so funny, weird how some screens are greenish and others are bright yellow. Crossword has failed me. I think they would have bought me better TVs. Cheap guns. How'd the SAT go yesterday, kids?
That's fine.
No? You? Is that what you said?
Yeah.
Okay.
Oh, can I ask you a question that was on it? I had no idea how to do something. There's
You know how to-
one math problem that was.
Can you wait a couple minutes?
Yeah.
Yeah, sure. Thanks for sharing, Faith. In case you didn't hear, Faith still has to go to the bathroom. Now we've recorded that for prosperity's sake. So years from now, you'll be able to go back to that video and, hey, remember the time I really had to go to the bathroom? It's on YouTube if you want to see it. Or hear it, I guess. Well, all you would see is that, but you'd hear it.
Oh, do you actually upload some of these to YouTube? Like, I know they're on our Schoology, but I didn't know you put them on YouTube.
That, yeah, I put them on YouTube and then put the link from YouTube on Schoology. Yeah, so they're, if you prefer, you could watch them on YouTube.
You put a new one every year.
I've saved all the old ones, but I recorded a new one every year.
What if one day you just have all bad recordings? Then you upload it other ones?
Then you're either on your own or I go and find an old one and put that up. Well, like I can't stop swearing. Remember the Tuesday when you kept dropping F-bombs? You didn't use any of those videos. That would be fun one day, wouldn't it? Let's talk about this MF lesson. We're done, day 76. So let me stop the recording and then we'll talk a little bit about the schedule. Discard, thank you. And